of the Indian National Society of Soil Mechanics and Foundation Engineering was established in 1948. This came soon after the Second International Conference on Soil Mechanics and Foundation Engineering held in Rotterdam. The society was affiliated to the International Society in the same year, and since then it has strived to fulfill and promote the objectives of the International Society. The name Indian Geotechnical Society was adopted in 1970. The vision of the founding president, Mr. Khosla, and the honorary secretary, Dr. N.D. Gulati, was to build the society to promote cooperation amongst engineers and scientists for the advancement and dissemination of knowledge in the fields of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, snow and ice mechanics, and allied fields and their practical applications. As the geotechnical community started to grow, the International Society decided to have regional conferences for each continent, along with having 4 yearly international conferences. This is when the first Asian Regional Conference was held in 1960 in New Delhi. India also hosted the 5th Asian Regional Conference at Bangalore in 1975 and the 13th one at Kolkata in 2007. IGS has been organizing national conferences annually in different cities since 1961. The Silver Jubilee Conference was held at Kurukshetra in 1973. 1978's GeoCon was a landmark conference held at IIT Delhi, which was inaugurated by the then Prime Minister Morarji Desai. IGS started the prestigious annual lecture in 1978. A tradition followed till date. The first one was delivered by Professor R.K. Katti. Several others who delivered the annual lectures include Professor Dinesh Mohan, Professor T. Ramamurthy, Dr. R.K. Bhandari, Professor Gopal Ranjan, Dr. B.G. Rao, Dr. N.V. Nayak, Professor G.V. Rao, Professor A.V. Shroff, and most recently, Professor M.N. Viladkar. IGS made an impressive debut in the international scene in 1994 with the organization of the 13th International Conference on Soil Mechanics and Geotechnical Engineering that was held in New Delhi. This was one of the biggest conferences in the history of the International Society, and it firmly put India on the international map.
24 years ago, in 1994, the Indian Geotechnical Society organized the 13th International Conference on Soil Mechanics and Foundation Engineering in New Delhi. This conference was a great success. Everything went perfectly as planned. Its technical sessions, its exhibition, its field trips, its delegate interaction, its companions program, its entertainment, and hospitality. Dr. Parry, the Secretary General of the International Society, in his concluding remarks, branded the conference as the Magic Carpet Conference.
The turning point came from the 12th Annual Regional Conference in Singapore, which saw more than 20 Indian participants and the keynote lecture by Professor Madhav. We were successful in winning the next ARC at Kolkata and also Professor Madhav as Vice Presidentship for Asia for the term 2005 to 2009.
The major visible contributions from Indian Geotechnical Society have been in the latest 21st century. A large contingent had attended the Singapore Asian Regional Conference, followed by election of Professor Iman Madhav as the next Vice President for the term 2005-2009. Several of our members have been, members of IGS have been members of the technical committee, and the most recent achievement of our society has been the keynote lecture or plenary lecture given by Professor Babu at the Seoul International Conference. With the kind of enthusiasm and activities of the Indian Geotechnical Society and its members, I look forward to a much more greater role for IGS in the international community.
The Golden Jubilee Conference was held in 1998 at Delhi. IGC has hosted the council meeting of ISSMGE at Bangalore and the 6th Asian Young Geotechnical Engineers Conference very successfully thanks to great efforts by Professor Sitaram, Professor Srinivas Murthy and the team. IGS was successful in bidding for the 6th International Conference on Environmental Geotechniques to Delhi in 2010, which was a great success with due to Professor Manoj Datta's great efforts. The international community has become aware of our true potential, with several of our members becoming active in several technical committees of ISSMGE. IGS has a full-fledged office in New Delhi catering to the needs of its members. IGS publishes a quarterly journal since 1962. It is now accessible online to all IGS members free of cost. Since 2012, the journal is being published by Springer for qualitative improvement and international reach. It has wide circulation and is retrieved internationally. IGS also publishes a quarterly newsletter to keep its members abreast of all geotechnical events.
Hello, AP Singh sir.
IGS
Welcome
operates through its
webinar.
local chapters that keeps its flag
Good
high in
morning.
different
Good
cities
morning,
of
sir.
India. With 44 active chapters, IGS has spread its reach to every part of the country. Some of the active local chapters include Delhi, Roorkee, Mumbai, Indore, Pune, Goa, Surat, Bangalore, Chennai, Kolkata, Guwahati, and several others. To encourage the chapters, an annual Best Chapter Award was instituted in 1995. The Delhi chapter has won this award a record 5 times. The geotechnical industry in India is incomplete without its partnerships with geologists, earth retention system contractors, consultants, and public sector organizations. Institutions like the IITs, CSMRS, CRRI, CBRI provide industry-academia interaction so that the benefits of research reaches the industry and the industry can input to the academia what the thrust of the research should be. This helps in directly applying the findings of the research on the ground for real implementation. With the growing demand for land, we have skyscrapers sprouting up in every big and small city in India. As industries grow, demand for power and power plants also increases. Connecting the industries through bridges, highways, railways, and metros, the Indian geotechnical landscape only shows a promising future. This also means that there is a demand for quality work as the margin for error is nil. Today, IGS is working towards setting up a joint assessment for testing soils along with the National Accreditation Board for Laboratories, the NABL, to match the quality of testing with the international standards. IGS is also working with the Bureau of Indian Standards to prepare Indian standard codes in several aspects of foundation design and field and laboratory testing. Many of our members serve in these committees.
The future is very bright and full of optimism. A number of initiatives have been taken up, promotion of student chapters in various colleges and institutes to sensitize the students about the importance of geotechnical engineering in their curriculum and the practice. Creation of number of professional groups to make them aware of the future challenges and opportunities in geotechnical engineering. A number of initiatives such as interactions with other professional groups that are overlapping with geotechnical practice are also initiated. It's hoped that with all these initiatives and further initiatives that one can have at IGS level, there could be better geotechnics in the country, which ultimately lead to better, cleaner, sustainable societies.
The future of geotechnical engineering lies in the hands of today's students. Recognizing this, IGS has set up student chapters in some cities, several more in the offing. As we celebrate the 70th year of the Indian Geotechnical Society, the possibilities that we look forward to are limitless. Here's to saluting the past, celebrating the present, and welcoming the future.
Nestled among the mighty Himalayas stands a temple of education, an institution that shapes young minds of today into ambitious, conscientious, and dauntless individuals. Individuals who will become leaders of tomorrow. This is Jaypee University of Information Technologies, Solan, where education meets excellence. Conceived as the joint vision of the Government of Himachal Pradesh and the founder chairman of Jaypee Group, Shri Jaiprakash Gaur, JUIT Solan is the first private university of Himachal Pradesh established in 2002. Over the last 2 decades, JUIT Solan has been relentlessly pursuing its mission of contributing to a better world by cultivating creativity and advancing fundamental knowledge through education among students. Adorning the picturesque slopes of Waknaghat hills in the Solan district of Himachal Pradesh, the university campus spread across 25 acres provides a peaceful and serene setting in the lap of nature for young minds to hone their skills for a brighter future. JUIT offers undergraduate, postgraduate, and doctoral programs in various fields of study, to include computer science and engineering, information technology, electronics and communication engineering, biotechnology, bioinformatics, civil engineering, and management.
JUIT has been producing polished graduates who are working as experts in various fields in country and abroad. More than 200 alumni have become acclaimed professionals in countries like Canada, America, and also Europe.
As Dean Academics and Research, I have had the privilege of witnessing a remarkable journey here. We aim to provide an educational opportunity to one and all, irrespective of their background. In JUIT, our main aim is to produce industry-ready professionals and good human beings. From the beginning, our institution has been known for its research and innovation, and now it emphasizes on interdisciplinary research and collaborative work. We are also aligning with the principles of NEP 2020, and following NEP, we are preparing the students to excel in their professional journey. We have been continuously ranked in NAC and NIRF. Now we are also ranked in international rankings such as the Times Higher Education ranking and QS ranking.
We regularly upgrade the IT infrastructure at our university. Recently, we have added a good number of new machines in various labs.
With modern hostels for both boys and girls, faculty residences, a healthy and hygienic students' mess, auditorium, sports facilities, and other amenities. The university campus makes life vibrant and enjoyable for students, both inside and outside the classroom.
Handling 1900 students in the age group of 17 to 23 years is challenging. In JUIT, we create a conducive ecosystem for a student to develop and nurture his or her personality besides the academic curriculum. Providing excellent amenities in the hostels, good nutritious food, active sport fields, vibrant and diverse co-curricular activities clubs, NCC, etc. are all domains which fall in my responsibility as the Dean of Student Welfare.
The university exposes its students to placement teams from several well-known companies, and the students here in this university do get placements in the organizations like Microsoft and Amazon.
JUIT Solan stands tall as an institution committed to academic excellence, holistic development, and industry relevance. With its focus on research and innovation, as JUIT graduates step into the professional world, they carry with them not only knowledge but also the skills, values, and perspectives necessary to make a positive impact on society.
So, hello everyone. Thank you for a very patient listening of yours. And now we have our speaker for the day, Dr. N.K. Samadhiya, who have joined with us for presenting the second lecture. So before that, I welcome you all, the members of the IGS, the members from the engineering community, the students and the research scholars who have joined us today for that special lecture. So I welcome you all in the second lecture of the webinar series, Advances in Geotechnical Engineering, which is jointly hosted by IGS Shimla chapter and Civil Engineering Department, JUIT Waknaghat. So welcome to all. So before we get on with the lecture, let me introduce the speaker for the day. So Dr. N.K. Samadhiya is a professor in the Department of Civil Engineering, IIT Roorkee, and is an expert of rock mechanics, slopes, and underground excavations. He served as a president of Indian Geotechnical Society for the term 2021 to 2022 and has contributed a lot in upliftment of the Geotechnical Society. He is chairman of the Rock Mechanics Section Committee, CD 48 of BIS since 2019. He has actively involved in the research, teaching, and consultancy related to geotechnical engineering in general and rock engineering in particular. He is the recipient of the IGS Professor Leonard Bynel Prize 99-2000 for Best PhD thesis in geotechnical engineering. He has also got 7 IGS Best Paper Awards and 7 ISR MTT Best Research Awards, besides ISR MTT Excellent Performance Award 2018 and IGS Legend Award in 2022. Sir has commendable experience in the research field. He has published over 200 research papers in national and international journals and conferences. He has guided over 17 PhDs and 85 MTechs till date, and presently is also guiding around 8 PhDs and 2 MTechs. He has participated in the Ministry of Education sponsored leadership for academic program at Kolkata and IIT Kharagpur and Cambridge University in UK in 2019. He is an active member of TC 205, meant for the safety and serviceability in geotechnical design, and TC 207, meant for soil structural interaction and retaining walls of International Society of Soil Mechanics and Geotechnical Engineering, which we call as ISSMGE, and also International Society for Rock Mechanics, ISRM India. So with this little introduction, I will like to welcome our speaker for the day, Dr. N.K. Samadhiya, to please enhance and enlighten us with his lecture. Thank you, sir, and over to you.
Thank you, Dr. Neeraj Parihar, for nice introduction. So let me share my lecture. Can you see this on the screen?
No, sir.
Sir, no, sir, not now.
Now?
Yes.
It's okay now.
अब दिख रहा है sir.
Okay. Slides are changing now?
Yes, sir.
Yes.
Yes, sir, yes, sir.
Okay. So, very good afternoon to all of you. Today I am going to present a theoretical derivation or the lecture regarding the design of a rigid cutoff wall. And as far as the role of geotechnical engineering is, it is to find out the passive earth pressure and active earth pressure. Since most of the audience is the student, so I'm sure that if you have passed third year soil mechanics and foundation engineering, this will be very useful for you in the sense that the concept is very simple. And with this concept, we can design the cutoff wall, rigid cutoff wall, which can be used for the levees, for small earthen dams. And this is actually the work of PhD of Dr. A.K. Singh, who is Associate Professor, Department of Civil Engineering, NIT Jamshedpur. So I would like to acknowledge him before I start this lecture. Now, everybody knows about flood and how devastating these floods are. Now, especially in India, some areas are severely affected by the floods. So it is a natural menace. It leads to the loss of lives, properties. So we will have to build the suitable structures so as to safeguard the property as well as life. Now, there are many flood control structures or elements available, and out of them, these levees and flood walls are very common. Now, here I would like to just quote this, that water is the source of mankind, but enemy of geotechnical engineer. In the sense, whatever failures take place, it is because of water. Whether these are the landslides or a photograph showing the failure of a levee. Now you can see here, if levee fails or the structure fails or the embankment fails, how devastating it could be. Although the water has played a vital role in shaping civilization. Most of the civilization have been developed along the water sources, whether these are lakes or rivers. But for geotechnical engineer, whatever problems we face, mostly it is because of water. Now I'm showing some of the photographs which are taken after the flood. Now these photographs you will find in websites, several websites. Now all these photographs are available. So these are the old photographs of like aerial survey of the flood affected areas in Bihar in 2008. You will find similar from 8 to 24. There are so many photographs you will find in the net. Now here you can see this particular levee has failed. And because of the failure, the water is entering into the property. Now, this is the photograph of the Srinagar city, 2015. Now you can see here, this entire city is flooded with water. This is another photograph of the Srinagar city. Now this is the failure of a flood wall. Here you can see that because of the failure of this. And this is from the 17th Street Canal Flood Wall Beach and Lakeview section of New Orleans flooded. So this is another photograph. So you will find number of such photographs, number of such devastating failures all over the world. Some of the photographs are from India. Now coming to the levees. Now these levees are the world's oldest hydro engineering structures. Now you will find these levees are, if you belong to Bihar, now all along Ganga plains, you will find several levees are constructed. Not only that, along Ganga, other rivers are also. There are canal levees also which are constructed. Now the purpose of these levees is to control flood and safeguard land, properties and living beings. Now these are also built to facilitate navigation, irrigation, recreation, and to prevent saltwater intrusion. Now it is a simple earthen embankment of small height. Height will depend on what is the width of that particular river or the canal. So both the river levees and canal levees are very much similar to earthen dams of medium height. So these are nothing but simply the embankment. So just to summarize, it is an earthen dike or embankment. It is used for the flood control and constructed along the river. The purpose is to safeguard the water entering into the property, flowing water into the property. Now, as far as the construction is concerned, it is similar to the construction we do it for the highway embankment. Material is placed in layers and compacted. And height and top width of the levee, that depends on the highest flood level of the river. So we will have to keep a freeboard also. So similar to a canal, we will have to keep a freeboard. So the levee cross section, it is adjusted to fit the site and available material. So mostly it is constructed by the whatever material is available at that particular area. Now normally the top width is 3 meters, usually recommended, and riverside protected by stone pitching. So on one side, on the river side, we can place the pitching, and on the countryside, it is protected by the turfing. Now sometimes, in some of the cases, turfing is also not there on the countryside. Now these run along the river bank with a margin of 2 meters between the toe of the levee and the top of the river bank. Sometimes it may run some distance away from the river, means these can be constructed very close to the river boundary line, or maybe away from there. Now this is another photograph of a levee. Now levees can be man-made levees, or it can be classified as the natural levees also. Let us say you have got a river or a, let us say, drain. Now during flood stage, what will happen? Now sediment will be there in the water, and after the flood is over, initially the final particles coarser particles will be settled down, and after that you will find that there is a formation of an embankment, natural embankment type of thing, and these we call it as the and after many floods you will find these levees are formed. Now these are located on both the banks such that sufficient area of flow is provided between them. If floodplain between levees is shallow and flat, then channel width will be large and therefore height of the levee is low. But if you have got a deep and narrow floodplain, that will necessitate high levees. So when a city or agricultural district is to be protected, a rain levee may also be provided. Now, the failure of these levees, these result from the quicksand condition, and piping in the foundation soil due to high seepage pressure, and this is highly dangerous in the water retaining structures. So there are remedial measures, and the first approach is it involves reduction of the quantity of seepage, which may be achieved by providing anti-seepage elements of passive protection, like we can go for sheet pile wall, cut-off wall, slurry trench, clay ceiling, upstream impervious blanket, grout curtain, concrete wall, diaphragm wall, etc., etc. Whereas the second approach, it involves providing a safe outlet for seepage water, which still enters the hydraulic structure or the foundation, and this may be achieved by providing anti-seepage elements of active protections, such as filters, drains, sand drains, stone columns, ditches, and relief beds. So these levees are the passive one. I mean the cut-off walls are the passive one. Now, sheet cut-off wall is normally used. It is one of the common anti-seepage measures taken in the water retaining structures, in dams, in reservoirs, in levees, flood walls, weirs, irrigation and power generation canals, etc. Sheet pile cut-off wall may be flexible or may be rigid. Like thin steel or concrete sheet pile cut-off wall are treated as flexible, whereas thick steel or reinforced concrete sheet pile cut-off wall are treated as the rigid one. Now, when the depth of the sheet pile cut-off wall exceeds about 9 to 15 meters, it is less expensive to derive steel sheet piling than other provisions for seepage control. Now, as far as the design is concerned, now all these cut-off walls have been designed, are being designed on the basis of the analysis given by Tarjagi in 1954. Now, Tarjagi, they have suggested graphical method for the computation of the active earth pressure, flow net for the determination of water pressure in upstream and downstream side, and analytical method for the passive earth pressure. So what we will have to do, we will have to simply draw the flow net, and from the flow net, we can find out the water pressure which will be acting in the upstream. And whereas they have also suggested some analytical methods for passive earth pressure determination. Now, this particular method given by Tarjagi, it pertains to retaining wall with vertical drainage layer acts as the surface of seepage. It is not necessary to compute the seepage force acting on the failure waste separately. So Tarjagi has not recommended or has not used the actual seepage force which will be acting on the failure wedge, which is adjacent to the cut-off wall. But in case of cut-off wall, there is always water pressure acting on either side of and therefore the seepage force in triangular wedge is to be computed exclusively. So this is what is discussed in this particular presentation, that we should also find out the water pressure which is acting on the other side of the water pressure as well as the seepage force. Whereas Tarjagi has not considered the seepage force, they have considered it indirectly. What they have done, they have considered submerged unit weight of the soil, and which is reduced by the average seepage pressure per unit volume, the mass of the soil. And that is used as the unit weight of soil for computation of the passive earth pressure. The unbalanced water pressure between upstream and downstream side is combined with the active earth pressure. So that is not, they have combined it with the active earth pressure. The resultant thrust acting on the cut-off wall was obtained by subtracting the passive thrust from the combined unbalanced water pressure and active thrust. So there are critical gaps. And those are the magnitude and direction of seepage force changes with the volume of the critical soil wedge. You know that the seepage force acts in the direction of flow, right? And hence the magnitude, and depending upon when you draw the flow net, you know the direction of the flow line, and you can find out the direction of the seepage force which will be acting on that particular mass which is considered. So the seepage force is likely to change the angle of failure plane of the soil wedge also. Now normally in the analysis we assume that the failure wedge is inclined at an angle of 45 plus 5 by 2 if you are going for Rankine theory, right? But if you consider the seepage force, that will change the angle of failure plane also. So the computation of active and passive thrust and their angle of failure plane without considering the actual seepage force is not justified, and it needs verification. And that's what has been done by us in this particular study. So the proposed method is the seepage force acting on the soil wedge is calculated accurately in both upstream and downstream soils. The magnitude and direction of seepage force changes with the volume of the critical soil wedge, and the seepage force is likely to change the angle of the failure plane of the soil wedge also. So the active and passive thrust acting on a rigid cutoff wall have been quantified by considering limiting equilibrium of forces, including the exact seepage force acting on a triangular failure wedge. Now, an equipotential function and pore water pressure in the flow domain are obtained through conformal mapping. So I will not be going in the details of this. If you want, you can. I will give you a paper, and you can read it from that paper. And this we have referred this book by M.E. Har, very good book, especially for the seepage. And the exact seepage force has been determined both graphically and analytically using the boundary pressure method, which is given by Cedarville. Or otherwise, also what you can do, if you have the flow net, you can find out the water pressure, pore water pressure, or the pressure head at different location all along the height of the wall, and then you can find out the seepage, the water force which will be acting on the wall. And the passive thrust acting on the seed pile cutoff wall is compared with that obtained by Tarjagi's simplified approach. And the present study deals with the rigid cutoff walls with flexible base only. So the statement of the problem is, now we are considering this as rigid and an impervious levee. And this is the flexible base here. And you can see it is simply an embankment of a small height. So on one side, it is the water is flowing, and this is the countryside. And when seepage takes place from higher potential to the lower potential. So this is a flow line, and we can draw the equipotential line also. We can draw the equipotential line also, and we can draw the flow net, right? Considering this as the impervious base. Considering this as the impervious base. So in this particular condition, in this particular case, now here you have got this boundary. This is equipotential line on this side. This is another equipotential line on this side, and this is the flow line, which is like B, C, D, E, and F. That is the flow line. Now, height of the levee is HL, and the height of the water column above this base, it is H1, and the water here is H2. So the head causing flow is H1 minus H2, right? So this is the simple statement with a rigid cutoff wall. So in the present analysis, wall friction is neglected in computation of the earth pressure. So we have considered all these walls to be smooth. Now that may be the limitation of. Now the analysis is very simple. You have to simply determine weight of the wedge, what are the tangential forces, and what are the coercive forces on the upstream as well as downstream. Now, in case of if we are considering this wall, so this wall on the upstream side and the downstream side of the wall. Now, this wall can be placed here, it can be placed on this side. So there are advantages and disadvantages, or not disadvantages, advantages of placing this wall at either at the close to the upstream or close to the downstream. Now we are here, what we are considering upstream and downstream means upstream of the wall and downstream of the wall. So there are various possibilities, like when failure plane intersects the downstream slope. So if you consider a failure plane from here, then okay, failure plane. So you can have a failure plane like this, or a failure plane can be like this, or a failure plane can be like this. So it can be like failure plane intersects downstream slope, or when the failure plane intersects the crest of the levee, or when failure plane intersects upstream. Only thing is the weight involved, weight of the soil mass which is involved, that will change, and remaining things, other things will remain same. So here this is the case of a levee. So this is the top width, and you can see here that this is the angle theta, that is the angle of the failure plane, and this is the failure plane which is intersecting the downstream slope. So here what you will have to do, you will have to simply determine the weight of different components. So here this is for, I am considering this triangle EDI. So weight of this soil in the foundation along with a force, this is the seepage force which will be acting at an angle alpha, right? So this weight W1. Now this is the embankment, and we are not considering seepage taking place through this because we are considering this as the impervious. So here this is the weight W2 and W3. So W2 plus W3 is the weight of this particular levee, whereas W1 is the weight which is, and then on this particular failure plane, you will be having the normal force to this, and then the resistance, coercive resistance in the foundation, coercive resistance in the levee, and similarly the frictional resistance. So you can calculate this T1, T2, etc., and then you can find out the active earth pressure. So if you consider the free body diagram of this particular, then on this side you will be considering, because active earth pressure will be acting from this side of the wall. But since you are considering the free body diagram of this, so PA will be acting in this particular direction. So D is the depth of the cut-off wall, and HL is the height of the levee. And different distances you can mark it from the downstream too. I hope it is clear. So with this, we can calculate the HS, which is the height of this HS. So by simple trigonometry, you can calculate this HS, then horizontal distance DTL, this is the DTL. Again, by simple trigonometry, you can calculate this DTL, and you can find out the weight of the wedge in the upstream side in foundation, and this you can simply, so this is the simple, this area multiplied by unit weight multiplied by unity, that will give you weight. Now when the failure plane intersects the downstream slope, so what will happen when it is intersecting the downstream slope? So this is the angle. So different components you can calculate. You can calculate the W2, you can calculate W3, and also the cohesive forces which will be acting on the that particular portion of the failure plane which is in the foundation and which is in the levee. So from that you can also calculate the cohesive force in the foundation and cohesive force in the levee. Now it is this the C1 and C2 may be different, and actually these will be different because one is in the foundation soil and another is the levee embankment material. Then we can also find out the T1 and T2 forces by simply resolving the forces in the direction tangential to the plane and the perpendicular to the plane. So here this N1 and N2 are the normal component which are acting on the plane, and then T1 and T2 will simply equal to N1 tan of phi r and N2 tan of phi 2 r. So N1 and N2 bar are the normal forces acting on the failure plane, and phi 1 bar and phi 2 bar are the effective angle of internal friction of the foundation and levee soil. And then we can also find out the normal force that will be component of W1 plus W2 in the levee portion, and N2 bar will be the component of weight in the foundation portion. Then the normal forces and reaction can be obtained by considering limiting equilibrium of the wedge, summation of all the forces in the vertical direction to be equal to 0, and summation of all the forces in the horizontal direction to be equal to 0. So simply by considering those forces, now we can find out the N1, N2. Now, if we are considering foundation soil or the levee to be cohesionless, then in place of that we can assume it to be C can be assumed to be 0. But normally it means we can consider cohesion, we can consider friction both. Now the third one is when the failure plane intersects the crest of the levee. So here you have these different components, so you keep on adding these weights. So here, if it is intersecting the downstream slope, you will have W1, W2. If it is intersecting the crest of the slope, it will also have W3. If you are considering it is in the upstream, then you can have. So by simple trigonometry, we can calculate W1, W2, W3, W4, and also we can calculate CL, that will be equal to cohesion multiplied by this length from here to here, and CF, that is the cohesion multiplied by this, and then you can resolve the forces, and you can also find out N1, N2, etc. Right? And then if you consider this block and these two blocks, then you can also find out this force R. Right? So force body diagram of wedge W3 and wedge W1, W2 combined for the force at face L1I in the upstream side. Now, if DTL computed from equation is greater than HL upon 10 beta and less than this, then the weight of the wedge W1, W2 will be same as obtained from these equations. Otherwise, so if from the trigonometry, you will have to simply determine these weights. You will have to simply determine these weights, W1, W2, W3, right? And if required, W4 also. So by simple trigonometry, you can find out these. Then the total cohesive force is obtained by using this particular equation. In the levee portion, the total cohesive force CL can be substituted by HS and W. So CL can also be determined. And the normal force by limiting equilibrium. And reaction R can be computed. So you can also compute this reaction R. Now, when the failure plane intersects the upstream slope, so you will have to calculate this W3, W4, and if required, W5 also. And whatever number of wedges you consider, then you can calculate. Now, so from trigonometry, we can find out this W3, W4, W5. So after obtaining all these parameters, then we will have to go for the seepage analysis. And from the seepage analysis, we will have to determine the seepage force. So all these forces are determined. All the weights are D1, T2, all the forces. Then On the downstream side, weight of the wedge and total cohesive force in downstream side are obtained by using. Now, in the downstream side, if you see the downstream side of the wall, in the downstream side of the wall, you will have this wedge, which is formed like this. And then from this wedge, you can find out the passive earth pressure. So, weight of the wedge and the total cohesive force in the downstream side are obtained by trigonometry, and then you can find out the total tangential force that will simply be equal to n10 of phi 1 bar. So these forces are integral part of the estimation of the passive thrust. And the seepage force, it is the magnitude and direction of seepage force. These are calculated by boundary pressure method, which is used by Sutherland. And if you are going for Tarjagi approach, then what they have done, they have determined this passive thrust in the downstream side of the cutoff wall that can be estimated by considering this in place of gamma dash. They have considered this as the gamma double dash, which is nothing but they have considered the submerged unit weight of the soil, which is reduced by the average seepage pressure per unit volume. So they have determined the seepage pressure and they have divided by per unit volume, and that they have included. So our approach is that no, we should actually determine the seepage, seepage force, and then the passive thrust should also be calculated using that particular seepage force. That is the main difference between Tarjagi and the analysis which is presented here. So in the proposed approach, what we have done, a trial soil wedge in the upstream side of the JUIT cutoff wall is considered as a free body diagram. All forces acting on the wedge are calculated. If you know the geometry, you can calculate the area multiplied by unit weight multiplied by unity will give you weight. So all those weights from W1 to W5, those can be calculated. And then the seepage force is superimposed over the soil wedge, where forces are to be analyzed for equilibrium condition. So in incorporating all forces in the horizontal and vertical. Okay, so incorporating all the forces in the horizontal and vertical direction for C5 soil, then using the limiting equilibrium. Now, resolving all the forces in the vertical direction and all the forces in the horizontal direction, you will get these equations in which that seepage force, which is inclined at an angle alpha with the vertical, that will also, you will have to take into account. That is the only difference from the Tarjagi theory. So this active earth pressure may be calculated by solving these equations. Right here, this active earth pressure is coming into picture here. So our procedure is repeated for calculating PA bar for various angles. So theta is varied from, actually, as per the Tarjagi theory or Rankine theory, this theta is simply equal to 45 plus 5 by 2 from the horizontal, right? So here this theta is varied, and then PA force PA is determined, and we know that by graphical procedure PA will be the maximum one. So a graph is plotted between PA bar and angle theta. So there is an angle theta for which PA bar is maximum, and that will be the active thrust. Now this active thrust will be different from the active thrust which we determined from the Tarjagi theory. So here, in order to determine the passive thrust, same procedure is now. In this case, in the active case, the direction of seepage force will be in this particular direction, whereas in the passive case, this, because the flow line will be like this. So here it will be in the opposite direction. So similarly, considering the free body diagram of this particular wedge, then we can also find out PP bar. Now, in order to find out PP bar, we vary this theta, and then using the equations, we can find out this PP bar here. So here, this PP bar can be calculated by simply, these are two equilibrium equations, summation of V equal to F V equal to 0 and summation of F H equal to 0. So PP bar is the resultant of the distributed stresses between the soil and wall acting on the downstream side of the cutoff wall. Process is repeated for various values of theta, and theta ranging between 45 minus 5 by 2 to 45 degree. A graph is plotted, and then whichever gives you, for whatever angle we get, for whatever angle theta we get, the minimum value, that minimum will be the PP bar, that is the passive thrust. Then we also find out the unbalanced water force. The unbalanced water force is the force developed due to the difference in water pressure acting on the wall on the upstream and downstream. So what we will have to do, we will have to draw the free body diagram of the cutoff wall. So here, this is the free body diagram of the cutoff wall. On one side, it is active earth pressure. On the other side, it is the passive earth pressure, and also the water pressure, which is acting on this side and this side. So the unbalanced will be the water pressure, will be the difference between these two sides. Okay, so the resultant thrust is the summation of the unbalanced water force and the difference between the active and passive thrust. So we will have to determine this unbalanced water force. Now, one illustrative example is here. It is considered to assess the design implications and to compare the results of Thursday method with the one proposed in this work. For the present, it is assumed that the angle of failure plane comprising wedge with respect to horizontal is 40 degree. So width, BT, HL, all these dimensions, depth of the cutoff wall, head water, height of the water column on the upstream side, height of the water column on the downstream side, strength parameters, different strength parameters, and then the side slope is 1 vertical is to 1.5 horizontal. Then the equipotential function and pore water pressure distribution in the flow domain under a levee with a sheet pile cutoff wall resting on pervious foundation of infinite depth have been obtained for given data at all boundary through conformal mapping. So here right now, I am not discussing that conformal mapping technique. So conformal mapping technique has been used. What you can do, you can also determine it by simply drawing the flow net, and at different points, find out the water pressure, pore water pressure, and then you can find out the. So here, in this particular case, this is the triangular wedge on the upstream side, and on the upstream side at different points these forces are determined all along the boundary, and finally the unbalanced water force is determined. So here this is the total force which is acting on this side. This is the from here we can find out the total force, we can find out the total force acting on this side. So these are the total forces, and then this is the weight of the soil mass, which is downward. And then we will draw, for this we draw the force polygon, right? So this force vertically acting like this force, another force, this force here, this force here. So whatever is the unbalanced, that is the seepage force, it comes out to be 14.4 kilonewton. Procedure is very simple. On this wedge, you find out the water force which is acting all along this line, find out its resultant, that will be normal to this, find out the resultant here, find out the resultant here, and then you can draw the force polygon, and then you can find out the seepage force, unbalanced seepage force. Then in order to find out the active earth pressure using those equations, for different angles, you simply find out the active earth pressure and then plot it. Whichever is maximum, that will give you the active earth pressure acting on the upstream side of the cutoff wall. So this in the tabular form, these calculations are given here. Similarly, in order to find out the passive earth pressure, you will have to determine, so that will be on the downstream side of the cutoff wall, and whichever gives, which at whatever angle it is minimum, that will be the PP. So these are the calculations which are given here. So from here you can find out that there is a difference of about 17 kilonewton per meter length in the passive thrust obtained from both the approaches, that is the Tarjagi approach and the proposed method. So, and also wedge angle, the downstream side is not necessarily equal to 45 minus 5/2 as inherent in the Tarjagi approach. So the assumption of the correct size of the triangular wedge appears critical to the design of a cutoff wall. So there will be we will have to determine the correct passive thrust, including the seepage force, and also the angle of the failure wedge, including the seepage force. Okay, so those have been determined. Then the resultant thrust obtained by proposed approach with upstream waterhead for C5 soil foundation has also been calculated. So that is given in the next table here, in which, so earlier C and 5 were not considered, here C and 5 are considered, right? So, and also the resultant seepage force have also been, and the unbalanced water pressure, water force, those have been calculated. Procedure is very simple. You will have to simply consider that wedge, and whatever procedure, whatever theoretical background you have, whether you can go for the conformal mapping, or whether you can simply draw the flow net, find out the water pressure. You know how to find out the water pressure if you have got the flow net. Then passive earth pressure considering wall friction can be derived by, again, those equations, and then we can find out N bar and PP bar, etc., etc. So those calculations are given in this particular table. Now it can be seen from these tables that for a cutoff wall of 4 meter length, for a small angle of wall friction, if you are considering wall friction, that wall friction 5/3, the passive earth pressure is increased by 9%. Whereas if you go for wall friction greater than 5/3, then the passive, it increases by 26%. Now, if you are not considering this particular seepage force, then you will be underestimating the force which is acting on the cutoff wall, and the cutoff wall will be designed on the basis of those forces. So that design of the cutoff wall may be erroneous. So for cohesionless soil, therefore N bar and PP bar can be calculated, and for different values of delta, considering the wall friction, the angle of internal friction of the foundation soil is taken as 25 degrees. So approach adopted in this paper may also be helpful in the calculation of resultant thrust acting on the retaining walls, cellular cofferdam, and under seepage flow condition. These results also reflect the resultant thrust developed on seed pile cutoff wall and required length of the rigid cutoff wall in the given conditions to save the hydraulic structures. So finally, to conclude, the influence of exact seepage force on active and passive thrust can be very significant. We have seen it. The active and passive thrust must be calculated by solving the equilibrium of forces only after superimposing the seepage force on a soil wedge. The effect of seepage force on the failure wedge has also been found to be considerable in both cases of active and passive thrust. And in the downstream side, the difference in angle of failure plane as compared to Tarjagi method is significant. So the proposed study may be very useful in determination of seepage force and its influence on active thrust, passive thrust, and resultant thrust which is required for the design of cutoff wall. Now these were the references, and here you will find that
environment for sustainability and in accordance with the IGS chapter of Shimla. So the links, everything are given there. You may please go to the link and upload the abstracts as per the desire. Okay, so we come to the queries session. So first query is from Aman H. Mishra. Sir, did the failure plane is pre-assumed in case of Terzaghis theory?
yes, that is 45 plus 5i2 and 45 minus 5i2.
Yes. So there is another question from him. Sir, how the angle of failure plane is decided in the real life problem in design approach?
No, in real life problem, that is what actually from this study, normally we consider this failure plane as 45 plus 5i2 or 45 minus 5i2 in the design of cutoff wall or seat pile wall or retaining walls, right? But if seepage is taking place, that will not remain 45 plus 5i2 or 45 minus 5i2. So you will have to include in the analysis the actual seepage force which is acting on the wall.
Right. I think you have described that very well in your lecture as well, that changes that angle whenever the seepage force is in picture. So there is another question from Mr. Naveen that I hope it is assumed that the cutoff wall will rotate about the base. Will this be the actual scenario?
No, actual scenario is totally different. When the force is taking place, it can displace also. And in Rankine theory, what we assume that the entire rigid wall is displacing, which is not the case.
Yes. There is another question from him. Sir, how the angle of failure plane is decided in the real life problem in design approach?
I think that is the same question.
Yeah, I think it is. Yeah, exactly. Okay, next question from Mayuresh, that what factors consider the design of soil cut wall for slope protection and why using geotextile or geocomposite material can be used for the same?
Just what factors consider the design of soil cut wall?
Yeah, I think he's writing some cutoff wall thing.
For slope protection.
Yeah.
What factors? No, question is not clear. Soil cut wall means, and why using geotextile or geocomposite material using the same? This question is not clear. Mayuresh, can you ask what do you want to? What is your question, Mayuresh? What factors consider design of soil cut wall? You are asking for the retaining wall, for the slope protection.
I think this is
slope protection in this is the soil protection wall. Soil cutoff wall is in a hilly areas, some tunneling portion part.
Soil protection wall.
Same as a
soil cut wall in the
same as a retaining walls. Same part, same as the retaining wall.
No, all those factors which we consider for normal retaining wall, like what should be the height, what should be the width, and the normal design we do as far as the analysis is concerned, whether we will have to consider whether failure in overturning or sliding in that case, and then slope protection. And why using geotextile? Now, in place of normal gravity retaining wall, we can go for MSE wall also. That will depend, or we can go for geocomposite material, we can go for geocell or Gavian walls, which are also used. Actually, your question is not clear to me.
Okay, sir.
Okay, sir. Can we go to the next question, please? So, which books do you recommend for seepage studies?
There are a number of books, and this IITR is the best one. And in otherwise also, if you are in undergraduate, then the textbooks, the textbooks written by Indian authors and as well as the foreign authors, those are more than sufficient for the background which is given in the undergraduate courses.
Okay, so the next question
But best is written by what I consider. What I consider best may not be the best, but what I consider best is the written by IITR.
Right. So another question is from Manav Kaplan. How will we determine whether the failure wedge will intersect downstream or crest? How does the soil affect the wedge failure?
Okay, that's what. Actually, when you consider that angle theta of the wedge, right? So you will have to simply draw a line from the bottom of the sheet pile, bottom of the cutoff wall, and just so wherever whether it is intersecting, because in order to determine the active earth pressure and passive earth pressure, what are we doing? We are varying theta, right? And whichever theta gives you the minimum or maximum, minimum for passive and maximum for active, that will give you the so if suppose angle is less, if you just consider the upstream side. If angle is less, it may consider the upstream face of the levee also.
Okay, sir, I think that doubt must have been clear. Next question is from Ashish Solanki ji. Sir, any views on land sinking 80 to 100 feet overnight in Bikaner?
Actually, I had visited Bikaner once, and the soil condition is the culprit. We have the highly plastic, highly compressible, and also plastic clay, and the water table, it may be, it is very close to the surface. The strength of that particular soil is quite low. That may be the reason that there may be sinking of, because we have visited a place in which all the quarters, I think it was some army area, cracks were developed. The cracks were developing after 6 months only, after the construction also. So that the main culprit is the soil there.
I think a very similar case happened abroad as well. I don't remember the country, but there also the people like faced those problems. That entire first floor was like sinking below the ground level after some time. So that how the clays behave at some places. So another question from Dr. Boshare. Sir, is there any special book to study soil water? I think it's soil water. Okay, soil water. Please suggest.
No, soil water from what point of view? I think if it is related to the seepage, as I said, it is IITR, a very good book.
Okay. Arindam sir has asked one question. Samadhiya sir said it is only for students. Even we are faculties, we are still learning from him. Thank you, sir.
Good afternoon, Arindam.
Good afternoon, sir.
Open your video.
Yeah,
if it's possible.
Hello, Dr. Arindam.
Hello, Neeraj.
After a long time.
Yeah, long time. So anyways, I did not have a question. I was just listening to you and enjoying the talk.
Yeah,
actually,
what you have said is
in this
true,
paper, only a concept is given. That is very simple also. It's not very complicated.
Actually, lot many things can be done from there.
No partial differential equation, nothing.
Yes, yes.
A
Yeah,
simple-
actually, lot many things can be done from there, as you rightly mentioned. Okay, okay, I will not hinder anymore.
Thank you, sir. Thank you very much. So moving on to next question is from Akhil Sharma. If we program or code the wedge failures, will more number of wedges affect the convergence of the program?
If the program or code the wedges failure, will more wedges affect the convergence of the program? No, no. Now you can write a code, you can write a program. Whatever calculation we are doing manually, we can do it by writing a simple program. Even in Excel, you can keep this and calculate. It has nothing to do with the number of
I think it is more to be done with the slope stability problem.
that is different. That is different. In this particular case, our aim is to simply find out that particular angle at which we are getting PA and PP. That's all.
Yeah. Thank you, sir. The next question is from Aman. The unbalanced water force is decided by FBD in case of three body diagram, in case of cutoff wall. In case of flood, it might be extreme. So is there any software based approach to do the analysis?
No, I'm not aware of any such program. Otherwise, there are number of programs available for seepage.
Yeah.
Now, what is the difference? Only in the analysis, what are we doing? We are simply finding out the seepage force. That's all. Right? So any program, if you have any program which is dealing with the seepage analysis, that is good enough. You can draw, or even graphical procedure also.
Right. Yeah, there is one question from Sophia Ne. Thank you, sir, for this excellent lecture presentation. My question is about the use of geosynthetics in levees. What type do you recommend?
No, geosynthetics, yes, this geosynthetics can be used in the downstream portion of the levee. In the downstream portion of the levee, now the purpose will be different. Now here the lecture is totally different from this use of geosynthetics. Now you can use it as a drainage filter. Now in place of a conventional filter, you can use geosynthetics.
Okay, there is another question from Araman. What is the difference while analyzing a high embankment and a levee?
No, high embankment, as far as the analysis is concerned, there is no difference. Only thing is levees are of medium height. Right?
Right.
The purpose is different. Their purpose is to, if you are going for, let us say, dams, the purpose is to store water or retain water on one side, right? But here is simply to guide water, which is flowing water. You have to simply guide it.
Okay, sir. Thank you for this. I think we are done with the written queries. If anyone has another question in mind or want to ask it directly to the speaker, they can unmute themselves and ask the question, please.
Thank you, Solanki ji, for attending this lecture. Are you there?
Yes, sir, I'm here, sir. Thank you so much, sir.
Okay.
So, sir, I hope we have done with all the queries.
Yeah, AP Singh. Okay, thank you so much. If there is no other question.
Okay, sir. Thank you. Thank you very much. The feedback form has been shared with you. I'll share it once more with you. Please fill out that feedback form. And with this, we are highly thankful for you, sir, for deriving such a great time of yours and for educating not only the students but to faculty as well with this problem.
Okay, thank you. Thank you so much for giving me the opportunity to interact with especially the students.
Yes, sir. And thankfully, a lot of students have joined in the today's lecture. I think everyone would have been benefited with this.
Okay, thank you so much.
Thank you. Thank you, everyone, from side of IGS Shimla chapter and also from Civil Engineering Jaypee University. Thank you. Please don't forget to again join us tomorrow at 11 a.m. There will be a very nice lecture by Dr. Rajesh on the slopes, on the foundation design on slopes. So please, we'll meet again tomorrow at 11 a.m. Thank you. Thank you, everyone. Thank you very much, sir.
Okay, bye.
Bye.